National 5 Maths Practice Paper I, Paper 2, Question 14. Now in this question we're told about greenhouse emissions, and they're looking to reduce it by 50% by the year 2050. Now we're starting with 2010, going to 2050, so that's 40 years, so that's 4 lots of 10 years. So when we're doing the calculation we're going to use a power of 4. Now it doesn't actually tell us what the current greenhouse emissions actually are, so we're just going to use X to represent that. Now if we're going down by 15% each year, that is 100%, subtract 15% is 85%, so we're going to use 0.85 as our decimal. So we're going to multiply the original amount by 0.85, so 15% reduction per year, and it's over 4 decades, so it's to the power of 4. When we do that, we get 0.52x. Now you might think, well that's more than 50, so yeah, they're okay, they've got past 50%, but they've gone from 100% down to 52% of the original, so it's actually only a 48% reduction. So 100% subtract 52% equals a 48% reduction. So will the scientists' recommendations have been achieved by 2050? No. Emissions have only been reduced by 48%. So we're close, but not quite there. And in number 15, we're told about the depth of water in a harbour. Now, you know, harbour, the water's going to go up and down with the tides. And we're given the equation where H stands for the number of hours after midnight. So if it's a 5 AM, that means it's 5 hours after midnight, so H is equal to 5. So to work out the depth at that time, it's D equals 3 plus 1.75 sine 30 times 5. Now that can just be typed into your calculator and you get a depth at 5 AM of 3.875 metres. Now for part B, I'm going to show you 2 ways of doing it. One way is slightly longer than the other, but it helps you understand it a wee bit better. But I'll show you the other way as well. Now, just a reminder of the equation. D equals 3 plus 1.75 sine 30h. Now we can look at each different part of the equation and think about what it would do to the graph. This part here changes the period. That doesn't change the maximum, minimum. That doesn't have any effect on that at all. So it's these numbers here we're going to look at. Now, ignoring the 3, if you've got 1.75 times sine, that tells you you're going to have a maximum value of 1.75. And then your minimum value is going to be negative 1.75. Now that's if that plus 3 wasn't there. But because we've got this 3 added onto it, that's shifting the whole graph up by 3. So that takes you up to 4.75, and plus 3 onto the minimum takes you up to 1.25. Now the difference between the maximum and the minimum is 4.75 take away 1.25, and that gives you 3.5 metres. So that is the difference between the maximum depth and the minimum depth. So that's a slightly longer way of doing it. Now the other way of doing it is you can think about this number here just tells you how much up and how much down it goes essentially. So if this 3 wasn't here, you'd have a sine graph. The 1.75 would tell you it's 1.75 above, 1.75 below. The 3 just shifts the whole lot up, but that doesn't change the difference between that and that. So that number from here all the way to here is 1.75 plus 1.75, or just 1.75 times 2, which would be 3.5 metres. So you didn't actually have to do all this bit here. We could have just taken that number there and doubled it to get 3.5 metres.